Good morning, everybody. I hope that you enjoyed the keynote with Joe from Microsoft and Matt this morning. And thank you for joining us for this first session of ISV Partner Day. My name is Chris Chandler. I'm the Microsoft Alliance Manager for Microsoft and have the pleasure to introduce Richard Erwin at GitHub.
Excellent. Right. Well, good morning, everyone. It's a bit of an honor to be the first in this virtual conference. A slightly weird scenario, or a slightly weird feeling compared to what we were expecting to have in London. Okay, so my name is Richard Erwin. I'm a solutions engineer at GitHub based out of the UK, currently isolating in Devon, which hopefully my internet connection will handle this as expected. So we'll do a little bit of mix of slides and demos in this session, but I thought I'd start off with a little bit of a history. Now, many of you may be very aware of GitHub and been using it for some time, but others may be coming from perhaps using some other tooling and maybe not as familiar with GitHub. So GitHub it was created in around 2008, back when you could have Git repository hosting no longer a pain in the ass as your tagline. And of course, it was a hosted Git platform. Git itself was obviously released in around 2005 as part of the development for the Linux kernel. So 2008, GitHub was created, and a lot has really happened in the intervening 12 years. Probably most of that is the fact that we now have 40 million plus developers. I think that's around 44 million right now, but it's increasing all the time. There is a very interesting report that you can go and read. It's called The State of the Octoverse. You can find that on the GitHub page, and it just gives some numbers around really the staggering numbers of the users of GitHub. So I say 40 plus million developers. That probably includes about 10 million new just in the last year. About nearly 2 million students have learned code on GitHub. So there's a vast amount of users on there. There are about 124 million, and again, these numbers are probably low from what they are right this very minute, but 124 million repositories on there. And that could be from a little bit of coursework, a hobbyist project, up to the very largest open source projects, but a huge amount of code sitting on GitHub. And of course, we like to think of GitHub as the home of open source. It's the #1 developer platform on the planet, and it's really just a social platform on top of the Git version control system. So most large companies will have some form of presence on GitHub. And probably some of the reasons why in 2018, so only 10 years after GitHub was created, that Microsoft purchased GitHub and brought that under the banner of Microsoft. Still operating very separately, but again, you've seen some massive amounts of innovation coming since the acquisition. Now, there's probably a few good reasons why Microsoft paid all that money to buy GitHub, but probably #1 is that open source is changing how the software is developed. Now, you might think, well, we don't really use open source software, but in fact, a study a couple of years ago on open source showed that about 96%, so pretty much all deployed applications have some form of open source in them, and in quite a few cases, not just a small amount, it's rather a large amount of that code base is based on open source. There is again another part of the study showing that 80 to 90% of new applications will be built on open source, and I say that is quite often a very large part of the application, but that's not something to worry about. Why do we need our developers reinventing the wheel? Why do we need to have them building a new API for something that already exists? So they can use these components and concentrate their time in adding the value in adding their domain knowledge to the application, driving that innovation rather than, as I say, reinventing the wheel. So if we take a look at that, and again, you may be sitting there thinking, well, we don't really do open source. It's not, we may have a few public projects on our GitHub site, but we don't really do open source. But of course, open source effectively has won. It has been proven to be a successful way of developing software. It's done with huge amounts of developers working on these projects, and again delivering some very successful outputs. So what can we learn from that? And again, we may not be doing open source, but what can we learn from the way open source development is completed, and how can we bring some of that in internally? If you look at a typical organization, and again, I speak to a lot of companies, and I see this over and over again, where you will have a business unit, and they will be working in development. They have their own developers and testers. They work maybe largely in one programming language, and that's it. They are a little silo. They don't necessarily speak to other business units. They don't know what other business units are doing. They don't share code, and so they're only concerned with the work that they're doing. And so what often you will find is that, perhaps you're at the company offsite, you get chatting to someone, and you find out that actually they're working on something very similar to you. They're building the same API that you are to talk to that internal business system. And of course, what would be ideal is if we could find that code that exists within the company, but behind our firewall, and actually reuse some of that. So we find that most organizations struggle with finding existing development that's going on within the company. Now, if we look at a typical kind of reporting structure, we have a number of teams reporting up to maybe a unit manager and so on. And we look at how those teams might communicate. Now, you can take that a little bit further and add maybe a few thousand people on there and say, well, okay, that's a sort of a reasonably large size company. But if we have some developers working across that business, and they might be working on something very similar, maybe, I don't know, let's say some machine learning, or maybe they're JavaScript specialists, how can they communicate with each other? Who would you speak to? How would you find out that they exist? So that's what we really want to try and pull from the way open source development is done today. Now, if you look at I suppose some of the key principles of how open source development is completed, we can look at that and say, well, okay, we have a number of these tenets, these principles, that we're open, transparent, participative, collaborative, and governed. So what do we actually mean by those? Let's go and have a look at some of those. Now, I've got a few screenshots here from a project called Electron. You may not have necessarily heard of Electron, but of course, that is the code that underpins things like Slack, Visual Studio Code, Teams that we're using today. And that was what we call an inner source project within GitHub that then went and became an open source project. So again, we're using some of those screenshots today, but talking about those principles, so open and transparent, the idea here is that anyone can view the code, anyone can have a look at that application, look at the work that's been done on that, look at the code changes, the proposed code changes, and see all the information about it. Now, if we take that into the enterprise, it's about allowing people to find that code, and if they want, they can actually contribute to that code. How do we make that possible? How do we make it so that they can find it? And we may use things like topics on our repositories. We may make sure that everyone is in the same version control system so that we can search across those business units and find like-minded projects and like-minded people. And if we look at this, the difference really being open and transparent. An open restaurant is very inviting. Hey, come in, have a look around, take a look at what we offer. But a transparent restaurant may have that open kitchen. You can see where the sausages are made, and that's what we're talking about here. So if you take the example of you may look at a project and you say, hey, look, why don't we move this to, I don't know, a NoSQL database? And the typical response you get, nah, that wouldn't work. We've tried that before, and you just have to take that as that's the situation. But what if you could say, well, look, we tried that last year, and if you go and take a look at this issue that we have documented on here, you can see how we failed, we had a problem with that, it didn't work, and go and read essentially the post-mortem of that attempt. So again, making everything we do, the successes and the failures, open to the people who can view that project. Now, the next thing is, again, making the project, allowing people to participate in that project. Now, again, I love this little screenshot here, and this is just coming from an issue, but what it shows is a different way of working. So again, let's say I am dependent upon maybe an API that's produced by another business unit within the organization. Now, we find that actually we need an extension to this API. We need it to do something else. So what will we do? We'll raise an issue with the team. We'll raise a change request or whatever might happen. And that would go off to the team for them to look at. But of course, what happens is they have their own priorities. They have their own work to do, and that thing never makes it to the top of their backlog. So it doesn't get done. So what if it's a case of, well, look, we want this change, but rather than requesting that team go and do it, why don't we do it? So we will submit a pull request to go and essentially implement that change. The team can then take it through their review process, take it through the release process, and then we get that much quicker. And again, it's a different way of working. It's about encouraging people to make those updates, make those changes, and submit requests for us to bring that into our code base. And of course, we want to make that as easy as possible. So how do we have a contributing guide? So we want to have a markdown file within our repository that tells everybody exactly what they need to do, how they contribute, what we expect from them, and how they can get involved. So make it as easy as possible for those teams. Then, because of that, if we start to invite those teams in, and we invite those developers to contribute to our project, what we can start to do is build up teams that go across our organization. So here we have a kind of a typical set of teams. So we've got group A, B, and C, and they work on their projects. That's fine. They're all traditional silos. But what we might do now is start to build up teams that say, okay, what about all the JavaScript developers within the company? Let's make them part of a team. And then we might say, well, who's involved in security? Who's interested in security? Let's bring them into a team as well. And again, maybe something like SQL as well. Now, what happens then, we have a user here who is a developer in Group A, but is a member of the security team and the SQL team. So all I have to do within an issue or a pull request is mention that team. So I can say mention security team, and they will be notified. And again, I get more eyes on the code that I'm working on. And of course, that's all well and good. So you say, hey, why don't we get all these developers from other teams to come and submit code and so on into my project? But that's quite a scary concept. I don't want all their code coming in if it's not of good quality. And I don't want to spend my entire time reviewing the code that they submit. So we need to make sure that we maintain the quality, and also the conduct that we expect for our team as well. So for that reason, we can use, again, things like contributor guides, codes of conduct. We make sure that people know what we expect from them. So what language are we using? How do we write our code? What style do we want in our code? Make sure that they're following that. And then, of course, automation becomes a big part of that. Before I even get to a manual review and getting physical eyes on that code, I need to have that automation in there. And so that automation may be just running my continuous integration, running my unit tests. But of course, it should also be things like thinking about security analysis, static code analysis, making sure that the code is in the style that I want it. And again, that could be almost anything, but building those automated checks before I even go and think about reviewing that. So I mentioned inner source before, and you may hear, especially if you listen to a GitHub presentation, you may hear this term, inner source. And really all we're saying with the term inner source is it's about taking those learnings from the open source community and using them to drive our DevOps processes within our company. And how can we make use of those and improve how we're doing our development? Because if we look at the benefits of open source or inner source, if you like, if we're using that internally, there's a number of really kind of key benefits there. So the quality of the code, we're getting more eyes on that. We're getting those automated checks to make sure that we're keeping the quality bar high. The efficiency of reusing, whether it be packages and code. So rather than, again, me thinking, well, I need to go and write this this code, maybe it already exists. Let me go and try and find that. And again, making those things available to people to go and find, hopefully, we reduce some of the effort that we're going. Now, the other key thing here is things like innovation and morale. So of course, if I'm a developer, I'm working on a project, and maybe it's not the most exciting project, but I've got ideas, I've got a real interest in a particular area, then what I can do is I can go and look at what else is happening in the company. Maybe in my spare time, a little bit of downtime, I can go and contribute to something that I'm more excited about. And so maybe I can eventually get a shift over to that project, or I can raise my profile a little bit. But it's rather than trudging away in a very not exciting project, I can also be part of something bigger. And of course, again, I'm bringing my ideas and I'm hopefully driving the innovation across the company. So there's a few practices I would say will help make that up. In fact, I just realized I updated that slide to make it look a little prettier. And there's a couple of things that we might want to do. And of course, it's about having those maintainers of a project, or the project that it's my responsibility, it's my job to work on that project, but also building up a community of people who are interested and are bringing those fresh ideas. We're going to drive that community within the business. Asynchronous communication is another thing. And again, in the current scenario where we have, shall we say, people who have childcare responsibility, but also trying to fit in that full-time job working from home. Well, what happens if I miss that Teams meeting or that Zoom meeting? I don't know what happens. So what we have is asynchronous communication to say, well, okay, you are everything you do is going to be recorded in that project. So every discussion we have is all done asynchronously. So I can always catch up. I can always see what's happening. And again, we have that documentation of what has been tried and what's working within the project. And of course, we're not doing that big bang deployment. We're doing iterative development that most of you will probably be doing already with more agile processes. But the other two key things: code reuse, package management, and building up that automation and the continuous integration and continuous deployment. And last year, you may have heard of the announcement around GitHub Actions and GitHub Packages. So Action Packages, again, a CI/CD system, a way of storing my binaries, my packages within, or very close to my code, again, within GitHub. And you may already have tools that do this, and that's absolutely fine. The GitHub Actions is a very powerful CI/CD and flexible CI/CD process within GitHub. And of course, if you've used something like Azure pipelines, it will be very similar to see things like hosted Linux, Macs, Windows, and Windows containers. Now, I won't go through all of that. We'll go and do a little demo and have a look at this now. But there's a couple of reasons why you should kind of care about this, and I think this is the difference and why we are going to see Actions go from strength to strength. There's two parts to this. Number one is the community part Actions. So I mentioned right at the start of the session that we have 44 million odd developers within GitHub. Every single one of those can be building actions for your workflows. Now, if you go to the GitHub marketplace and filter down by actions, I did this just the other day, and there was over 3,000 actions that you can pull into your workflows. So again, harnessing that community, everybody's got their own requirements, their own ideas, and they will go off and they can build those actions. And so, of course, you can then consume those as well. But it goes further than that, because again, maybe it didn't go into the marketplace. Any action, anything that I can use in my workflow can just simply be some code in a repository. So I can search across all of those, whatever it was, 124 million repositories, have a look in my .github folder for a YAML file, and hopefully find somebody who's doing something similar. So again, we're using that to build the code reuse and educate people about how they can work with actions. There's a very nice repository on GitHub, which is called Awesome Actions, and again, just a third party who is curating a whole list of interesting actions that you can use. So that's one thing, and I said there were two. So massive community driving all the things that I can do with actions. The other part of that is not just a CI/CD tool. It's not something that's just going to build my code, maybe deploy that to an environment. It's about automating my whole DevOps process. So any trigger that happens within GitHub, be it somebody creating an issue, commenting on a pull request, I don't know, editing a wiki file, anything that happens, I can then react to that change and run a workflow. So there's a ton of then opportunities to really start to build in the automation around my process. So even if I'm using another tool to do my build, I'm going to build automation into my process using actions. Okay, let's go and take a look at that. Let's see how we're doing for time. We're good. Excellent. Okay, so let me do this. So I'm gonna just drag across my project. And of course, the wonders of running a virtual conference. I had to switch machines just before the session started, so I'm not quite as prepared on this machine as I'd want it to be, but we will get through. Okay, so this is my GitHub page. I have a little repository in here. Now, I just created this a little while ago, and effectively all it is a really simple SP.NET Core application, so just generated that, threw it into a repository, and just made a couple of little changes to that. Now, what the scenario we've got here is that, again, somebody has come along, they've added a dependency to this project, and straight away the GitHub security alerts is saying, well, look, you have a potential security vulnerability in one of your dependencies. So what I can do is I can just go and view that security alert, or I can pop over to my security tab here and I'll go and have a look at my dependency alerts. So my dependency alerts is saying, hey, somebody has added something here and it doesn't look quite right. There's a known issue. In fact, in this case, it's a critical severity. And what we're seeing here is saying, look, here's the CVE that it refers to. It's critical. You really should take care of this. And all you need to do is move that version up to 1.81. I think we're using 1.8 here, and that's got an issue. So again, it's letting me know that this thing exists. Now, what I can also have is a tool called Dependabot, which takes this change and said, look, you've got this issue. We need to move the version up. Let me go and create a pull request for you that will then go and fix that. So I didn't have to do this. It just went in, went into my CS proj file in this case, or my package.json file, or whatever it needs to use, makes that change, and then submits the pull request for me to include. And so of course I can now take that, I can again go and see the details of it. Hopefully it can give me some idea around compatibility. In this case, it doesn't know. And I'm ready to merge. Now, you can see here that all my checks have successfully passed. I can have a look at this and saying that I have something that was executing here. Now, in this case, it's a GitHub action. It's a build that is happening, and I can go now have a look at that. Now, you can see here, I don't have any reviewers on this either, but what I can obviously do, because I want to control any kind of contribution to this, I'm going to pop to my branches here. I'm going to set up some branch protection rules. And in this case, I'm saying, okay, let's say it's my master branch. I do not want anybody to contribute code to my master branch because, of course, I'm going to go off and deploy directly from that. So what I can do is say I need to have a review of this code before I can even consider merging it. And I might say that maybe 2 or 3 people have to review that code before it is available to merge. I can also use things like code owners files. So if this is, let's say, a JavaScript file that is being changed, it will have a look at the code owners file, say this is the person in this repository who is responsible for JavaScript, make sure that they are one of the reviewers. So I can add that as well. I can have required status checks. So you can see here, it's found a few existing checks which have been completed. And it's saying, which of these would you like to make compulsory? You must pass this check, otherwise you cannot submit that code. So we can add those things on. I'm not going to bother at the minute, so I'll go back to my pull request. And as I say, you can see from that there were some checks which had completed. Now, again, this could be another tool that's running as part of this. It doesn't have to be GitHub Actions. I can see here my .NET Core build was successful. So what I'm going to do, I'm going to look at my Actions tab, and I can see a number of these all going off and running successfully. And if I want to go and view, let's say, my .NET Core build here, again, I get the full logs coming out of that, and I can go and view those as before. So all that information is coming out of that. But let's have a look at the actual action itself or the workflow itself. So I'm going to flip to my code. Now within this, there is a .github folder. And there's a couple of things that I've done here. If I pop into my .github folder, I've got some issue templates and I've got some workflows. The workflows are my GitHub Actions. Now, very simply here, I've got one set up called .NET Core, and if you've done any set up any builds as code, used YAML before, this will probably feel relatively similar. So the you can see here it's got a name, it's called .NET Core, and then it's got a trigger. So in this case, it's saying on push or on pull request. So if anybody pushes or submits a pull request to the master branch, this job will be triggered. Then I have a job, one or more jobs. In this case, I only have one called build. I set up some environments variables that I can use, and then I've got where that is going to run. So it's going to run on a hosted Linux runner, and it's going to use a couple of steps. Now, this is where it's kind of interesting. So I've got here a step, and it's saying it uses actions/checkout at v2. What that is saying is in the github.com action/actions repository, which is one obviously owned by GitHub, there is an action called checkout, which is going to get the code, pull it down to my runner, and I've specified a version, v2. Now that could be an individual commit, it could be a version, or it could be even a branch. So if I want to go and use the latest and greatest version of this action, which has been built by a third party or another company, then I can absolutely go and do that. And of course, you can see here I'm using a few different things. So I'm going to set up .NET Core. The Actions repository is owned by GitHub. Obviously, the Azure repository is owned by Microsoft, and they have provided, again, some actions that we can use within our workflows. So here I have a Docker login, which I'm logging into my GitHub Packages registry, and I'm going to effectively build my my little ASP.NET Core web application. Going to package that container image up, and I'm going to publish it here directly to my package registry. Now you can see here, I'm not calling an action. I'm not using a packaged GitHub action. I'm just running a little bit of a script. So I'm just saying Docker push, and I'm going to send that up to my image or my container registry. Okay, so really super simple. Now that's kind of what you would expect from a standard build system, but again, here's what's a little bit more interesting. So I've got one here called issue creation deploy to Azure. Now you can see by the name of my little repository, I'm planning just to expand this out to deploy to a few other cloud providers. But this one here is set up for Azure. Now, again, this is where it gets a little bit more interesting. So it's not just about pushing code, submitting pull requests. Here, I'm opening an issue. So I'm going to open a GitHub issue. And again, this could be opening up an item in another tracking tool if I want. But in this case, I'm opening an issue. I'm looking at the time saying, well, it's open, so therefore I want you to run this job. Then again, we've got a job called deploy to Azure. Then we do a little check here. So we've got some logic within the YAML file saying if this issue starts with, if the title starts with deploy to Azure, then we want to continue. So don't run this workflow for any random issue that's created. It must be deployed to Azure. Now you need to go and add some approval process in this. But again, we're keeping it simple for the demo purposes. And again, here we're going to run a little bit of a script which is just going to allow me to write information back to that issue. So again, we're building up that automation. It's just going to tell us where we are deploying it to and push that into the issue and give me some nice useful links within that. Then we're going to go and log into Azure. We're going to log into our package registry as well and grab that container image. Then we're going to, again, using some of the actions from Microsoft, we're going to deploy our container. And then again, we'll just write some more information on success of that. So if we go and quickly do that, hopefully we'll see. Now, again, another thing we mentioned, templates for our issues. So I'm just going to say a new issue. I've already set up a nice little template that we can use, again, making it really easy for people to contribute to this or give us the right information. So I've set that template up. It's already got the title in there. It's been tagged up with all the labels that we want, and we can go and submit that new issue. And what that should be doing now is essentially looking at the workflow. The workflow will be hopefully triggered because I've opened up the issue with deploy to Azure as the title. If everything goes correctly, it's now running, and great, we're halfway there. So we've got the kicking off deployment of my package, and again, while we're waiting in that, we can just quickly look at our action running. So there we can see there, deploy to Azure is off and running, and I can watch those live logs if I want. But I'll just quickly pop to my little project here, and what I can do is flip to packages. There's my lovely face, and I can see here this SP.NET app. That's my package all running in GitHub Packages, and of course I've got my latest version, which is available for deployment. So let's go back and see if my issue is running. In fact, let's watch my action and see if it's successful, and see if the isolation demo gods are smiling upon me. I did manage to break this this morning, and then I was hastily fixing it as well. So hopefully we'll be all good. But let's go and watch a little bit of the live logs, then we'll flip back to the slides. So my deploy to Azure off and running. Let's see where is that. So it's just creating the web app, and we may not wait for this to run, but deploying the container. Here we go. So let's grab that that package, deploying it out to the thing. And again, I created the web app within Azure. There we go. Post checkout, everything's running good. So if we flip back to the issue now, deploy to Azure, it's added another tag to that that issue to say it's been deployed, and then with a bit of luck, we can go and say successfully deployed, open that up in a new window, and there is my deployment up and running. And then the last thing, just really quickly to show you, is if I pop back to my code, go to my GitHub folder, again, pop into those workflows, I've got delete Azure deployment. And in this case, all we're doing is saying, hey, when that issue is closed, I want you to go and tear that down. So all I need to do, pop to the issue, it's already been deployed, we've seen it running. I'm done with that, that test image now, and all I need to do, close that issue, it will go off to Azure, delete my resources in there, and I'm not keeping things running unnecessarily long. Okay, let's flip back and finish off the slides, and then we're almost done. So just in summary, principles of open source, make it open and transparent, encourage people to participate in the project, make it very collaborative, but make sure it's governed so that we're keeping that quality and that conduct within our project. And then hopefully the benefits that we're seeing, the quality increasing, the efficiency of reusing that code, but also driving the innovation into our projects. And then for your developers, hopefully keeping that morale high, allowing them to use the skills that they've built, allow them to get involved in a project that they're interested in, even if it's not their core role. And hopefully we reduce the cost by driving the efficiencies within our project. Awesome. And I think almost on time. I am just about done. So I don't know if we have time for some questions from there.
Hi, Richard. It looks like thank you for that. It looks like there is already a question in the Q&A. Obviously, we encourage everybody to use that to ask additional questions. But the question is it possible to search the actions for support for different development languages?
Search the action for support for different development languages. Yeah, so again, you can effectively build actions for anything you like. So the workflow itself is built in YAML. The action, if I'm going to use a packaged action, is either a container image or it's just written in JavaScript, TypeScript. But in terms of actually building something, again, if I want to build an iOS project on a hosted Mac agent and use Xcode for that, then absolutely I can do that. So you can effectively build anything you like if you can script it. And again, there'll be a ton of actions that you can use for that. So actually building and searching that, there's not a necessary language tag on the issue, but it shouldn't be too difficult to find the ones that you're interested in.
Thank you. No other questions as far as I can see at this time. Give people a minute to see to have more in.
No problem. Well, I will check out the LinkedIn group as well later today. So if there are questions that pop into there, then I will make sure that I jump on and answer those.
Perfect. Thank you. So just switching back to myself. Thank you again, Richard. Oh, it looks like we do have another question in there. Can you run actions on-prem?
Really good question. The answer to that is almost. So watch this space, imminent. So for GitHub Enterprise Server, actions are imminent. Hopefully in the next few weeks. It's actually in beta at the minute, so you will be able to grab that. There are some third-party ways of running and debugging them locally as well if you want to do that. But I'm assuming the question will be using actions with GitHub Enterprise Server on-premise. And again, watch this space. It's very soon.
Okay, great stuff. Being conscious of time, as Richard said, please join the Grey Matter ISV partner community on LinkedIn to post any questions you might have post this session. But additionally, reach out to info@greymatter.com or give us a call. Up next is a session from April Edwards at Microsoft covering implementing Azure DevOps for continuous delivery and automation. Thank you all for joining us today, and look forward to see you in further sessions. And thank you again, Richard, for your delivery. It was a great session.